In this lesson, we'll explore an existing application and predict its behavior. Use the Getting Started window to create a project or open an existing project. This is an example of a project in LabVIEW. The Project Explorer window includes the following items by default. Project Root contains all items in the Project Explorer window. The label on the project root includes the file name for the project. My Computer represents the local computer as a target in the project. Dependencies includes LabVIEW programs and their required items. Build Specifications includes build configurations for source distributions and other types of builds available in the LabVIEW toolkits and modules. If you have the LabVIEW Professional Development System or Application Builder installed, you can use build specifications to configure standalone applications, shared libraries, installers, and zip files. When you add another target to the project, LabVIEW creates an additional item in the Project Explorer window to represent the target. Each target also includes dependencies and build specifications sections. You can add files under each target. LabVIEW uses different types of files. In this course, you learn about 3 types of LabVIEW files: LabVIEW projects, VIs, and custom controls. LabVIEW programs are called virtual instruments, or VIs, because their appearance and operation imitate physical instruments, such as oscilloscopes and multimeters. Today, LabVIEW VIs can be extremely powerful and sophisticated programs with elegant graphical user interfaces. Later in this course, you learn how custom controls can improve maintainability of your LabVIEW application. LabVIEW projects can also include non-LabVIEW file types. For example, you can include documentation files. To open an existing LabVIEW project, double-click the LVProj file. The Project Explorer window appears. Each LabVIEW project has one LabVIEW project file, which has a .lvproj file extension. A project also contains VIs, which have a .vi extension. A project can also contain folders. The Files tab shows all the files and folders in your project, which are also files on the disk. Here, I can open a LabVIEW program and run it. A LabVIEW program is called a VI. A VI has a front panel and a block diagram. The front panel is where the user can set values, run the VI, and view data. The block diagram contains the code, which defines the functionality of the VI. On the front panel, you use the toolbar to control the VI execution. For example, run continuously, abort execution, or pause execution. You can also use the toolbar to select the text settings, align, distribute, resize, and reorder the objects, search items, and open the context help. The front panel contains controls and indicators. Note that front panel objects appear as terminals on the block diagram. Controls are inputs. For example, the user can use this control to input the number of measurements to the VI. Indicators are outputs. For example, this VI uses this indicator to output the measured signal to the user. In LabVIEW, every object and wire is associated with some type of data. Here is a list of data types for objects on the front panel. A Boolean control allows a user to input a Boolean value, which has only two states. For example, on or off, true or false, clicked or unclicked. A Boolean indicator displays a Boolean result to the user. A string control allows a user to input text and typically has a white background. A string indicator displays and outputs text to the user and typically has a gray background. Notice that the string controls and indicators also include a scroll bar if necessary. The array data type groups multiple elements of the same data type. In this example, the array is a collection of numeric elements. A numeric array can be visualized as a list of numeric values or as a plot where each point represents a different numeric value. Hardware resource data types allow you to select the specific hardware resource you want to access. For example, you can use the DACMX task name control to select which DACMX measurement task you want to access. You can choose the DACMX physical channel control to specify which DACMX channel you want to acquire data from. Or you can use the VISA resource name control to select which GPIB instrument you want to communicate with. To access the properties of a front panel object, simply right-click the object and select Properties. In the Appearance tab, you can explore several settings for the object, for example, label, caption, or enabled state. In the Data Type tab, you can see the property defining its numeric type as floating point, and another property in the Display Format tab that tells the numeric control to display 6 significant digits on the front panel. On the block diagram, you can use the toolbar to control the VI execution and debug the VI. You can also use the toolbar to select the text settings, align, distribute, resize, or reorder the objects, to clean up the diagram, to search for items, and open the context help. The Functions palette contains the VIs, functions, and constants you use to create the block diagram and code your application. Here are some examples of how wires have different styles and colors to represent different data types. Here you see a broken wire because these terminals cannot be wired together. Their data types do not match. The input of the increment function accepts the following data types: number, timestamp, or analog waveform. This input also accepts an array or an array of clusters of the listed data types. The Context Help is a very useful tool to have open while you program in LabVIEW. You can show the Context Help by clicking Help, Context Help, or pressing Ctrl-H on the keyboard. The Context Help displays basic information about whatever LabVIEW object you hover your cursor over. To view more detailed information about an object, click on the Detailed Help link in the Context Help window. LabVIEW uses a Dataflow model for running VIs. The rules of Dataflow are as follows. First, a node can only execute when data are available on all of its required inputs. Then the node executes. Finally, a node supplies data to its outputs only after the node has finished executing. It's the flow of data that determines the execution order of a block diagram node. Therefore, a block diagram can have simultaneous operations. To find example code, select Help, Find Examples in the Getting Started window or in a VI. Expand the Hardware Input and Output folder. Then expand the DACMX and Analog Input folders. Let's take a look at some DACMX examples. You can start from a working example VI and modify it to fit your application needs. Or you can copy and paste code from an example into your own VI. When you double-click an example, such as Voltage Continuous Input VI, you launch it. Then you can switch to the block diagram and explore. Here's a summary of what you've learned in this lesson.